Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we are going to talk about simplifying radical expressions using properties of radicals. And it's very, very simple as long as we learn it. And the first property we're going to learn is called the product property of radicals. And it states that in order to multiply radical expressions, they must have the same index. So that means that they must have the same index. If the nth root of A is being multiplied to the nth root of B, you can multiply the insides if the indexes are equal. So the nth root of A times the nth root of B equals the nth root of A times B. Okay? Now, one thing that you may notice, n has to be greater than or equal to 2. Okay? Why does n have to be greater than or equal to 2? Sir? Thank you. You can't have a square root where the index is 1. Then it wouldn't even be a radical. Okay? So n has to be greater than or equal to 2. Now, let's move on. Can we simplify the products of each radical expression? Okay, why is this a no? Exactly. How about this bad boy? Yeah, this would equal cube root of negative 8, which would equal negative 2. Excellent. How about this bad boy? Now, not this way, but yes, exactly. Who said that? Good. We have already learned this before. I'm going to reteach it, I promise. But we did learn way back when that when you multiply the same bases, you can add the exponents. Now you're looking at that and you're saying, hey, that's great, Mr. Morrow, but they don't have the same exponents. They don't have the same base. Yes, they do. This is 7 to the 1/4 times 7 to the 1/5. Now I just reversed my rational radical expression, and I made it a rational exponent. I just turned the radical into a fraction. So when they have the same base, you cannot do this. 4th root of 49. No, you can't do that. That's wrong. But you can do what you just did right here. Okay? So now you're just going to go ahead and find a common denominator. So that's 20. That's 5. That's 20. That's 4. And that equals the 7 to the 9/20ths, which is the 20th root of 7 to the 9th power. Now, yesterday, remember we were teaching this yesterday, but I couldn't record. But yesterday someone came up with a nice little trick, and it's quite awesome what this gentleman did. And he said, Mr. Morrow, do you notice that if you multiply the indexes, that gives you the index on the outside, and if you add them, that gives you the 9? Yes, I do notice that. That actually comes from middle school. It's called the bowtie method of adding fractions. If you have 1/4 plus 1/5, the bowtie method states the following. You multiply the denominators, and you cross-multiply the denominator to the numerator. That goes to 5, that goes to 4. 5 plus 4 is 9. The numerator is the exponent on the inside the radical. The denominator is the index of the radical. Okay? Pretty cool. Now, for our sake, for our purposes, for the SAT purposes, if they asked you, can these radicals be multiplied? The answer is no. However, if I said to you, or rather the SAT said, evaluate, that's different. Now they want you to turn this into 7 to the 1/4 times 7 to the 1/5 to give you that whole 7 to the 9/20ths. That will be evaluate. If they just say, multiply these radicals, or can these radicals be multiplied? You can't multiply the radicals. You can multiply these, but not in radical form, but in rational exponent form. Does that make sense? Sir? Okay, like I said, on my test, if I say, can you multiply these radicals? The answer is no. But on my test, you know what I'm going to do. I'm just going to say evaluate. So at this point, if the bases are the same, you can do it this way. If the bases are not the same, you're out of luck, Chuck. Cool? You sure? Okay, thank you, sir. How about this bad boy right here? Yeah, it's going to be the fifth root of 10. Very good. How about this guy? Fifth root of 42. And then 42, that's 3, that's 6 times 7, which is 2 times 3 times 7. So there's no sets of 5, so I cannot break that down any further. How about this bad boy? Yeah, it says x minus 5 times x plus 5. For those of you who got it quick, I'm very proud of you. That's a difference of squares. Excellent job. And how about here? Here, remember what we did yesterday, guys. A lot of people are going to multiply the 72 and the 10. And they're going to have 720. They're going to have to break all of that down. Don't do that, in my opinion. In my opinion, I would not do that, okay? I would, well, let me see. Did I simplify it first or did I combine them together? Okay. So we could do it one of two ways. We could immediately go, wait a second. 72, that's 36 times 2, which is 6 with a square root of 2 here. Take out an x, I have an x left over. Take out a y times a y out here, square root of 10x. So that's going to give me 6 absolute value of x. Relax, guys. Absolute value of y. Actually, y squared doesn't need an absolute value because it's squared. So that's already going to be positive. And then square root of 20x squared. So I'm going to take out another x. So at the end of the day, I've got 6x squared, y squared, square root of 20. That's one way, nice way, easy way, pretty way. Sir? Yes, the x is absolute value because when I took out an odd, I got to put an absolute value. But at the end, it's not absolute value because it's not odd anymore. It's x squared. Now, or I could do the, yes, sir. Come again? Actually, yeah, you can break down 20. Good. So that's 4 times 5, so that's 12 x squared, y squared, square root of 5. Thank you, kid. 5. No. Wait. Yeah, you have that y out there, yeah. Okay. Now, let's go ahead and do it another way. I got the square root of 72 times 10 times x to the 4th and y to the 5th. This, sometimes people see this a little bit easier. This breaks down to 36 and 2. Now, if you don't know your perfect squares, I suggest strongly you learn them. And this is 2 and 5. So 36 comes out as 6. A 2 and a 2 comes out as a 2. Then I got a square root of 5 left over. Square root of x to the 4th is x squared. Square root of y to the 5th, that's y squared. And I have a y left over, which gives me 12 x squared, y squared, square root of 5y. Either way, you're going to get the same answer, boys. It just depends on how you want to work it. Okay? Talk to me, sir. Does that make sense, my man? Yes, sir? You have a question, Bubble? Okay, thank you. Yes, sir? I go numbers first, and then I go variables always. Yes, sir. Yes, sir, my brother. Thank you. All right, let's continue, my brothers. Okay, in math, we say that a radical expression is simplified when the radicand, that means the inside part, cannot be broken down any further. Okay, I can't take any perfect squares or cubes or fifths. I can't take anything out. In order to simplify radicands, Simply reverse the properties of radicals. Just reverse it. Procedure. Write each factor as the radicand as a product of two factors, one of which is a perfect power to that particular index. So this is where you should know your perfect squares, your perfect cubes. It's going to help you out a lot. Number 2, write the radicand as a product of two radicals, one of which contain perfect powers of the index using the product property of radicals. And 3, take the nth root of each power. So what does that mean in English? Well, it means this. I've got 5 cube root of 24. Okay, I'm going to think of a perfect cube here. What's a perfect cube that I can take out of 24? Perfect cube. Perfect cube. 18, no, 18 doesn't even go into 24, but 8 does. 8 times 3. So what's the cube root of 8? So this is 10 cube root of 3. Now, guys, for those of you that don't know your perfect squares or cubes, you can break it down, but I'm going to tell you right now, my brothers, no sarcasm. I'm just trying to be helpful. This is going to take you a long time. So if you're going to do it that way, that's fine, but be really quick about it. It's a lot quicker to know your perfect squares and cubes. At least your perfect squares and cubes. At least. That's really helpful. If not, you can always break it down. A 2, and a 2 comes out as a 2. 2 times 5 is 10, and you still have a leftover of 3. That's fine. That's good. There's no worries. There's no problem. You're going to get the right answer. The question is, will you have enough time? So just be careful with that, gentlemen. Here, 128. Again, I see a perfect cube. I see a perfect cube of 64. Right? 64 and 2, yeah. The perfect cube of 64 is 4. So I got a 4. Cube root of x cubed is x squared. And I've got a cube root of 2x left over. Guys, if you want to break it down, do it. God bless you. I'm not going to break it down unless I don't see the perfect cube. If I don't see it, then I will break it down. But if I see it, I'm not going to break it down. However, you are allowed to go break it down at home and make sure that you have the same answer. Okay, 54, I see a perfect cube here. Great job, brothers. Great job, brothers. 27 times 2, very good. Cube root of 27 is 3. Excellent. And then I have a cube root of 2 left over. Cube root of x to the 5th on x comes out, and I got an x squared left over. Does that make sense, my brothers? Okay, here. First, let's clean this up. This is going to be 4. Whoa, sorry about that, guys. A little board snafu again. Okay. A little snafu there. No big deal. All right. So I've got 4 minus, bless you, 20 is 4 times 5. So square root of 4 is 2 with the square root of 5 left over divided by 2. So this equals 2 minus square root of 5. This is just like when we were simplifying radicals, guys, for the quadratic formula or for completing the square. Please remember that this 2, it's a distributive property. It's a distributive division. This 2 gets divided into the 4 and into this 2. Never into the radical. Never into the radical. Never into the radical. Whole numbers and radicals, you can't multiply them together. Whole numbers and radicals, you cannot divide them together. Next, I've got negative 2 plus, okay, 32. Excellent job, brothers. 16 and 2, so that's 4. Square root of 2 over 4. Now, in this case, negative 2 divided by 4, that's negative 1/2. Plus 4 divided by 4, that's just 1. So I got a square root of 2 left. Because remember, this 4 goes to the negative 2 and to the 4. Okay, 20 times square root of 20x to the 10th. Bless you, that's 4 times 5. So that's a 2 with a square root of 5 left over. Square root of x to the 10th is x to the 5th. In absolute value. Good job. Well done, brothers. Here's 75 as 25 times 3. So that's 5 with the square root of 3. And 2 goes into y 3 times. Absolute value. Excellent. That looks ugly. Hold on. Does that make sense, my brothers? May I continue, gentlemen? Okay, next. Now let's multiply and simplify each. Okay, so this is the square root of, okay, 45, which is 9 times 5, right? Which is 3 square root of 5. Okay, let me show you another little trick that I do. Sometimes, especially if numbers get really crazy, I will not multiply that together. I'll break that up into this. I got the 3 times 15, but 15 is 3 times 5. 2 3's come out as a 3, and I have a 5 left over. You see that? That's really helpful for very large numbers, okay? Okay, now here is a great example of it. This is a fantastic example of this. I don't have a fourth root for 27, and I don't have a fourth root for 6. However, I'm going to go fourth root of 27 times 6, y to the 5th, w to the 11th. 27 breaks down into 3 times 9 and a 3 times 3. 6 is a 2 times 3. Circle the prime, and now I'm ready. I have a 3, a 3, a 3, and a 3. I have 4 3's, which comes out of the 3. And I've got a fourth root of a 2 left over. Does that make sense for the numbers part? I'm only working with my primes. That's why I circle my primes. I'm not circling it because I want to. I'm circling it because I have to make sure that I work only with the primes. I don't want to lose myself. And then fourth root of y to the 5th, a y comes out. I have a y left over. Absolute value. Good man, but I'm not done. I have another one. I want to see if that's absolute value as well. But thank you, brothers. I'm very proud of you. 4 goes into w to the 11th twice. So, yep, it's just here. W squared. And I've got a w cubed left over. Does that make sense, boys? Promise? Okay, let's continue. Here I got 3 cube root of 8x to the 5th. So what's the cube root of 8? 2. So 3 times 2 is 6. X1, you can take out 1x, not just an x, and then I have a cube root of x squared left over. Here I've got 4 times the cube root of 8 times 6, n to the 4th, m as in Mary, to the 9th. 8 is 2 and 4, 2 and 2, that's 2 and 3. I have a cube root, so a 2, and a 2 comes out as a 2. 2 times this 4 out here is 8. And I have a cube root of what left over as far as numbers go? A 6. I cannot take out 2 more 2's, and I cannot take out 3 more 3's. So I have 6 left over. Cube root of n to the 4th, I've got an n outside, an n inside. And cube root of n cubed, of m cubed, of m to the 9th rather, is m cubed. Does that make sense, my brothers? It's not too bad, is it? As long as you just break it down, it's not too bad. And if you know the more perfect squares and the more perfect cubes you know, the better. Heck, guys, I'm really proud of you that you know that the cube root of 27 is 3. It's going to help you. Cube root of 64 is 4. It's going to help you. Cube root of 125 is 5, by the way. Okay? And last but not least, same exact procedures here, guys, but now we're going to be talking about division. Just like multiplication, you can divide radicals as long as they have the same index. So the nth root of a divided by the nth root of b can all be put into one big fat nth root of a over b. I can divide the two as long as the indexes are the same. Okay, and this is wrong. This is not what is the simplest form of the equation. These are not equations. What are these, guys, when there's no equal sign? These are... Oh, good job, guys. Expressions. Well done. All right. So Square root of 18 to the x to the fifth divided by square root of 2x cubed. This is square root of 9x squared, which equals 3x absolute value. Okay, cube root of 160, bless you, cube root of 162 y to the fifth divided by cube root of 3y squared. This will be the cube root of 162 divided by 3, guys, that's 54. Thank you, my brother. And this is y cubed. 54 is 27 times 2. Cube root of 27 is 3. So this is 3y with a cube root of 2 left over. Same exact procedure as multiplication, except now you're dividing. But same exact procedure. Okay, this is a good one. Here, I can't divide, guys. Nothing goes into both 6 and 125. So what happens? Remember that in this case, it's one big fat unified one, right? But can't I legally produce two different radicals? Can't I produce the cube root of 6z cubed, which equals z times the cube root of 6, over the cube root of 125, which equals 5? So if you cannot simplify the interiors when it's in one big fat radical, separate them. Separate them. Does that make sense? Thank you, brothers. Go ahead, my brother, please. What do you mean, Papa?
You simplify them separately, and then you join them.
Okay, but what do you mean? How can I simplify 6 separately? Okay, you're saying could I have taken out a 3 and I had a square root of 2 in there? Yeah, that's fine. Thank you very much, my brother. Okay, so here. So this is what I think is what my boy's talking about. Well, yeah, but I don't like it like that. I like dividing it. It's going to make it easier. Because look, for this particular case, I've got a negative 2. Now I've got a cube root of just straight up 27, dog. See what I mean? But now, be careful. This is over cube root of x to the third. Look at what happened here, guys. This become negative 2 to the big fat cube root of 54x over 2x to the fourth. 54 divided by 2 is 27. That's why I brought it up. But down here, I got to bring this x down. That's x cubed. What's the cube root of x cubed? Okay, so at the end, what's the cube root of 27? So this is going to be negative 6 over x. We're running out of time, guys. Questions? We're going to make it. We're going to make it. I just got a few left. Does that make sense, though? Okay. Okay, how about this bad boy? In this case, I think it'd be wiser to make one big fat one first. Now remember, what did I say to do if there's a negative inside of an odd root? Take the negative out, exactly. Thank you, brother. So this is 375. This x to the negative 1 has to go up, so it becomes x cubed. This y comes down, because I always want to leave my variables of exponents positive, because y to the 6th. And wait, what's 375 divided by 3? It's 125. So this 375 divided by 3 is 125, my bad. X cubed over y to the 6th. Now it's easy. This is a negative 5 x over y squared. Okay, in this particular case, I cannot reduce this at all. So this is the fourth root of 10x squared over the fourth root of 81 y to the fourth. This literally is going to equal the fourth root of 10x squared over, what's the fourth root of 81? 3. Y. And then just a little review here. Can I multiply these two? Can I even use the little rational exponent trick here? No, you can't do it because you don't have the same base, so you can't turn into rational exponents. You don't have the same index, you cannot multiply those. How about this bad boy? Whoa. How about this bad boy? Now you can't do anything with that. Can't do it. Okay? Guys, I hope you learned a lot. Homework is completely 100% valid. Have a wonderful day. God bless you, and I hope you learned. Bye-bye.